Multiple linear regression and logistic regression are methods of multivariate analysis. There are many ways to classify methods of statistical analysis. One way is by the number of variables. Suppose that we are interested in blood pressure, and have data on systolic blood pressure and some other characteristics for residents of our community. First, we may want to look at the mean, median, standard deviation, highest value, lowest value, and so on, of systolic blood pressure for residents of the community. Each of these statistical computations uses just one variable, systolic blood pressure. Then we may want to investigate relationship between systolic blood pressure and some other variable. For example, we may be interested in relation between systolic blood pressure and age, and compute their correlation coefficient. Then we may proceed and investigate relationships among 3 or more variables including systolic blood pressure. For example, both systolic blood pressure and age may be related to some other variables, which may have some effect on correlation between systolic blood pressure and age. In that case, we may want to look at the relation between blood pressure and age, controlling for those variables. Statistical analysis of relationships among 3 or more variables is called multivariate analysis. Many methods of multivariate analysis may possibly be classified into 2 groups. Some methods are useful in summarizing associations among many variables, shown in this diagram as x1, x2, x3, and so on. Suppose we are interested in interrelationships among 20 variables. If we compute the correlation coefficient for each pair of these variables, we need to look at 190 correlation coefficients, one after another. But, these methods listed here help us to effectively summarize relationships among many variables into several patterns. This type of methods are heavily used in such fields as psychology and education. Methods in the second group are useful when we are interested in many variables with special focus on one of them, denoted here as y. We may want to investigate relationships of this y to the other variables, denoted here as x1, x2, x3, and so on, considering relationships among those x's. In some cases, these methods are used for predicting y from x's, and in other cases, they are used for examination of hypotheses on causal relationships. Various types of regression analysis and some other methods belong to this group. This type of methods are heavily used in public health research, which usually focus on a particular disease or a particular health problem. Y is called the dependent variable, and x's are called independent variables. In public health research, typical dependent variables include biomarkers, whether the person has the disease of our interest or not, if the person has some type of disability, and if the person died in a certain period of time. We often investigate how the dependent variable is related to lifestyle and behavioral characteristics, demographic and socioeconomic characteristics, and physiological characteristics. Physiological variables can be the dependent variable, but they also can be considered as determinants of disease, disability, or mortality. Variables used in statistical analysis have different formats, and different methods of regression analysis have been developed for dependent variables of different formats. First, variables such as blood pressure and BMI are numerical and continuous, because their values are numbers that can be considered continuous. Second, values of some variable are just counts. For example, the number of diarrheal episodes that a patient of some digestive disease experienced on the particular day is a count. The value can be a positive integer or 0, but the numerical value cannot be considered continuous, as there is no such a thing as having diarrhea 3.64 times. This type of variable is numerical and discrete. Third, some variables are not numerical, but are composed of 2 or more categories. For example, a person may be diagnosed as having a cancer, or not. In this case, the variable has 2 categories, and thus called dichotomous. Fourth, some variables have 3 or more categories. For example, a person may have diabetes, or prediabetes, or neither of them. This categorical variable is polytomous. Finally, although time is a continuous numerical variable, time has some special characteristics, so some methods have been developed for analyzing data on time. Different types of regression analysis have been developed for dependent variables of different formats. Linear regression is for a numerical continuous dependent variable, and logistic regression is for a categorical dependent variable. Regression analysis is used for analyzing relationships of one or more variables, denoted here as x1, x2, x3, and so on, to the variable of our interest, denoted as y. In different papers and books, These x's are called independent variables, explanatory variables, covariates, predictors, regressors, or factors. Meanings of these terms are essentially the same, with slightly different nuances. Y may be called dependent variable, response variable, outcome variable, and so on, with similar meanings and slightly different nuances. In this course, we use independent variables and dependent variable, because these names are relatively neutral, without special nuances. These two names are based on mathematics of functional relationships, in which the value of the dependent variable is determined by values of the independent variables. In notations used in this course, subscripts are important. Conventionally, x sub I indicates the value of the variable for the ith individual. X sub j indicates the value of the jth variable. If there are two subscripts such as x sub 2 and 3, it usually means the value of the second individual for the third variable. Although this course does not use many mathematical symbols, the summation symbol may be used frequently. In the next lecture, we will review simple linear regression.